what if I wanted to find maximum or minimum values of a function? Let's look at these four graphs here. And I think let's remind ourselves when we're asking about finding values of a function, we're looking for the y values. So if I'm looking at this function right here, and we're just going to assume that my function ends when I stop drawing it. So all of these are going to be on a restricted domain. So it's not continuing on and on forever. I think looking here, I would be able to say, oh, my minimum value is -1, and my maximum value looks like 3. So my maximum value is 3 for this one, my minimum value is -1. Okay, I'm just looking for my y values. Let's look here. It looks as though my minimum value is going to be -8 here. My maximum value looks like 10. So again, I'm just looking at these functions on a restricted domain and looking for the biggest y value and the smallest y value. Let's see here. It looks like my maximum value is a y value of 2. My minimum value here is a y value of -4. Here we have a max. Let's pretend that's a 2. And my minimum value, well, it happens in 2 different places, but that kind of doesn't affect my minimum value. The smallest value I get here is a y value of -3. Sometimes we call these absolute maximums and absolute minimums. Sometimes global maximums, global minimums, different vocabulary words are used. But if you're ever asked to find a maximum value of a function, it's the biggest y. If you're asked to find the minimum of a function, it's the smallest y. So where do these maximums and minimums happen? Well, I think you can see they either happen at the end points of my functions or at a turning point, at a place where my slope is 0 or where my slope is undefined. So let's go over a new vocab word. Whenever you have a function and its slope is 0 or its slope is, here's 0, here's 0, here's a slope that's undefined, here's a slope that's 0. All of these points that I've marked in orange, right? Not the endpoints. All of these points that I've marked here are called critical points. Critical points. Critical points are points in a function where the derivative equals 0 or the derivative is undefined. And critical points are critical here because they are candidates for my maximums or my minimums. So maximums and minimums happen either at endpoints or at these critical points. So the question is, well, how can I find these values if I'm not looking at a graph? Let's just do a couple examples. Let's try an example. So I have this lovely polynomial. I want to find the maximum value and the minimum value. I know that can happen either at endpoints or at critical points. I already have my endpoints since I'm just looking at this polynomial on this restricted domain. So all I have to do is find those critical points, the places where this derivative is equal to 0 or is undefined. Now this is a polynomial. I know it's differentiable, so I'm not going to have to worry about the derivative being undefined, but let's go ahead and find the derivative. And let's see, that's going to be -2x cubed minus 3x squared. So far so good. My board is dying here. Let's set this equal to 0 and factor. I like factoring out a negative in situations like this just to make my life a little easier. Okay, I think I did that okay. All right, so I know that my derivative will be 0 at x equals 0 and at x equals -3/2. These are the critical points of this polynomial. This is the place where the derivative of this function is 0. These are locations for a potential maximum, a potential minimum. How can we actually figure this out? Well, I like making a table of data. It's a nice organized way of keeping track of your data here so you know which is the biggest y, which is the smallest y. Remember, maximums and minimums can happen at endpoints or at critical points. So I'm just going to put in my candidates, endpoints, critical points. And now I just literally plug in my x value and find the y. So I'm going to be using my original function, of course, since I'm wanting to look at y values here. And this can be a little annoying, but it's not as bad as you'd think. That's -2⁴ is 16 times -1/2, so that's -8 plus 8, so we have a 0 there. -3/2, let's see, that's going to be -1/2 times 3⁴ is 81, 2⁴ is 16, and then minus a negative, so that's going to become a positive. 3 cubed is 27, 2 cubed is 8. Okay? So this does look a little annoying, but that's going to be a -81/32. Let's go ahead and just do that. -81/32. I'm going to get a common denominator, so I'm going to multiply everything by 4 here. If you do the math here, I think you're going to end up with, drum roll please, 27/32. All right, 0, that's much easier. 0 minus 0 is 0. If I plug in a 2, let's see, that's going to be -8 minus 8. That's a -16. Hey, so now let's compare our data. I'm thinking -16 is the smallest. So that is going to be, -16 is going to be my absolute minimum. And this crazy fraction, 27/30 is going to be my absolute maximum. So there you go. So again, we're always looking for the y values and identifying the y values. So -16 is my minimum of this function. 27/30 is the maximum of this function. Good. Just for fun, let's look at a graph of this and see if that seems right. Here is that function graphed. Yeah, okay, here's a critical point. -3/2, right there, boink. Here's a critical point at 0. We can see here that this critical point was a maximum. This critical point, neither a max nor a min. And then my other extrema, my minimum, happened over here off the page at 2, -16. Kind of cool. Should we look at one more example? Let's do. Okay, here we go. We want to find the maximum of this function and the minimum of this function on the interval, the closed interval, -7 to 9. All right, so my candidates are, my endpoints might be the locations for a max or a min, or my critical points, where my derivative is equal to 0, or where my derivative is undefined. Let's give this a whirl. Let's take the derivative. Let's see, we have 2/3 times x minus 1 to the -1/3. Chain rule times 1. We don't have to worry about that. That constant goes away. Ooh! In this situation, when I see a negative, I always like rewriting it so I really remember where this actually is. That is actually in the denominator. That x minus 1 to the 1/3 is actually in the denominator. Is this derivative ever going to equal 0? No, it's impossible. That derivative is not going to equal 0. So you might think, well, there are no critical points. Aha! But there is a critical point. Because I got so excited with that, I almost choked myself. There is a place where this derivative is undefined. Yeah, at x equals 1. G prime is undefined at x equals 1, which means x equals 1 is a critical point. I'll call a critical point a CP. It's a critical point. It's a possible place where we might have a max or a min. Maybe it's a cuspy thing like this or like this, right? The derivative wouldn't exist, but that could be a max, that could be a min. So it's a candidate. I'm going to make my nice table of data here. I'm going to put my endpoint values there and the one critical point I found. And let's now find y values. We're looking for the biggest y, we're looking for the smallest y. Okay, if I plug in a -7, so let's see, I'm going to rewrite it like this now. The cubed root of -7 minus 1, so that's -8, squared plus 5. Okay, the cube root of -8 is -2. -2 squared is 4. 4 plus 5 is 9. I know some of you are saying, wait, don't you have to square -8 first? I could. -8 squared is 64. Cubed root of 64 is 4. I like doing the cube root first because you're dealing with smaller numbers. Okay, plug in 1. 1 minus 1 is 0. 0 to the 2/3 is 0 plus 5. That equals 5. Plug in a 9. 9 minus 1 is 8. Let's see, the cubed root of 8 is 2. 2 squared is 4. 4 plus 5. Oh, 9 again. Oh, so what's my maximum value? 9 is my maximum. 9 is my maximum value. It's okay that it occurred in 2 different places. That's fine. 9 is my maximum, and 5 is my minimum. And again, sometimes we would say 9 is the absolute maximum value or the global maximum. 5 is the absolute or global minimum. Shall we look at a picture of this? Let's look at the graph and see if it actually seems to make sense. Here's the graph of g of x. Ah, there's the cusp, as we suspected. So here's a critical point at x equals 1. And we have this on the restricted domain from -7. So there's my maximum of 9 to 9. And there's also my maximum of 9 right there. Boink. So a minimum of 5 and a max of 9. All right. I hope you had fun. I did.